Close your eyes for a moment and imagine. 13,800,000,000 years ago, something extraordinary happened. The universe was born. Not in a specific place, because before that there was no place. Not at a specific moment, because time itself began at that instant. Everything that exists, everything we know, every atom in your body, every thought that passes through your mind now originated in that primordial moment. And since then, this universe has grown, expanding like a cosmic balloon in all directions simultaneously. More than 2 trillion galaxies float in this immensity, each containing billions and billions of stars. It's almost impossible for our minds to comprehend this scale, but perhaps we can begin with something closer, something more familiar. Think of the sun, that star that warms us every day. At this very moment, the light it emitted 8 minutes and 20 seconds ago is touching your skin, passing through your window. You are literally seeing the past when you look at it. That light traveled about 150 million kilometers through the absolute void of space to reach your eyes. And that space through which it traveled is of such complete, such profound silence that no sound has ever disturbed it. Sound needs molecules to travel, air to vibrate, and in the vacuum of the cosmos there is none of that. Only eternal silence. Our home in this universe is the Milky Way, a majestic spiral galaxy that stretches for 100,000 light years from one side to the other. Imagine this. If you could travel at the speed of light, the maximum speed limit in the universe, it would take you 100,000 years just to cross our own galaxy. And we, tiny beings on a rocky planet, orbit near one of the edges of this immense cosmic spiral. But we are not alone in this celestial neighborhood. Just 2.5 million light years away, our sister galaxy, Andromeda, glides through space toward us. In approximately 4 billion years, these 2 immense collections of stars will meet in a slow and majestic cosmic dance, merging into something even greater. Don't worry. This encounter will be so vast, so spacious, that the individual stars probably won't even collide with each other. The space between them is simply too great. In the pulsating heart of the Milky Way, hidden beneath clouds of dust and gas, lies something that defies imagination. A supermassive black hole called Sagittarius A, with the mass of millions of suns compressed into a point so small and dense that not even light can escape its gravitational pull. It is the invisible conductor that keeps our galaxy spinning in its cosmic dance. When you look at the night sky and see those countless twinkling stars, know that the universe has more stars than all the grains of sand on all the beaches of Earth. Each point of light is a distant sun, possibly with its own planets orbiting around it. And yet, with all this abundance of stars, the universe is predominantly empty. Well, empty might not be the exact word. Space isn't completely empty. Here and there, solitary hydrogen atoms wander through the darkness, remnants of that explosive birth so long ago. And there's something even more mysterious. Everything we can see, touch, measure, planets, stars, galaxies, even you, represents only 5% of the universe. The other 95% is composed of dark matter and dark energy, invisible substances that we cannot see or touch, but we know they exist because of how they influence everything around us. The fabric of space itself is not flat or rigid as we imagine. It bends, curves, and distorts under the influence of gravity. Massive objects like stars and planets create depressions in this cosmic fabric, like a bowling ball placed on a trampoline. And this curvature of space brings with it a fascinating consequence. Time does not pass in the same way everywhere. Near very massive objects, where gravity is more intense, time literally passes more slowly. If you could visit a black hole and return, you would find that much more time has passed on Earth than for you. The universe we can observe, with all our most powerful telescopes, is only a tiny fraction of something potentially infinite. There are regions of the cosmos so distant that their light has not yet had time to reach us since the beginning of time. And it may never reach us, because the universe is expanding faster than light can travel through it. In this vast cosmic ocean, the average temperature is nearly 273 degrees below zero, just a few degrees above absolute zero, the coldest possible temperature in the universe. It's a cold that freezes even the atoms in place. In the first 380,000 years after the Big Bang, the universe was so dense and hot that even light could not travel freely. It was an opaque cosmos, shrouded in a primordial mist. Only when it cooled sufficiently could light finally pass through it, and the universe became transparent for the first time. And here is perhaps the most poetic of all these cosmic truths. When you look at the stars in the night sky, you are literally looking into the past. That light that enters your eyes began its journey millions, perhaps billions of years ago. Some of those stars may no longer exist, but their light still travels through the void, telling us stories of a time long gone. You are not just looking through space, you are looking through time. Take a deep breath. Feel yourself part of this immensity. You are made of stardust, atoms forged in the heart of ancient suns that no longer exist. You are the universe contemplating itself. Now that we've journeyed through the depths of the universe, let's return to something closer, more familiar, but no less extraordinary. Our solar system, that little corner of the cosmos we call home. At the center of it all is the Sun, our mother star, a brilliant sphere of incandescent plasma that completely dominates this patch of space. Almost all the mass of the solar system, 99.86% of it, is concentrated in that golden ball of fire. The rest, all the planets, moons, asteroids, comets, and dust, are mere cosmic crumbs in comparison. If the Sun were a person in a room, all the planets together would amount to no more than a few grains of rice at their feet. The scale of this star is difficult to comprehend. 1,300,000 Earths could fit inside the Sun. Think about that while you relax. Every sunrise you've ever witnessed, every ray of light that has warmed your face, comes from this colossal furnace where, every second, millions of tons of hydrogen are transformed into helium, releasing enough energy to power all life on our planet. Closest to this furnace is Mercury, the small gray planet that hugs the Sun in its tight orbit. You might think it would be the hottest, being the closest to our star. But the universe holds surprises. It is Venus, the second planet, enveloped in a dense and toxic atmosphere of carbon dioxide that holds this grim title. On its surface, the temperature reaches 465 degrees Celsius, hot enough to melt lead into liquid pools. And here's something that challenges our intuition. A single day on Venus, the time it takes for the planet to complete one rotation on its axis, lasts longer than an entire Venusian year, the time it takes to orbit the sun. Imagine living in a world where the day is longer than the year. And then we arrive at our own planet, Earth, the only place in the known universe where life flourishes in abundance, the only world with oceans of liquid water covering its surface, where clouds of vapor dance in the atmosphere, where the complex chemistry of life has created a vibrant biosphere. We are, as far as we know, completely unique, a blue and green jewel floating in the black void. Just beyond us lies Mars, the red planet, that desert world that so captures our imagination. On its oxidized surface rises Olympus Mons, a volcanic mountain so immense that it makes Everest seem like a hill. At 21 kilometers high, it is the tallest mountain in the entire solar system. A structure so vast that if you were at its base, you wouldn't be able to see the summit. It would disappear beyond the horizon. And if you could visit Mars, you would feel your body lighter, because Martian gravity is only 38% of Earth's. Each step would be a small leap. And at the end of the Martian day, you would witness something magical. On Mars, sunsets are not golden or orange like here. They are blue, an inverted spectacle that would remind you that you are truly on another world. Further on, we cross the asteroid belt and arrive at the gas giants. First, Jupiter, the titan among planets. It is so colossal that all the other planets in the solar system could fit inside it with room to spare. In its raging clouds, a storm has been raging for over 300 years. The Great Red Spot, a hurricane so large that 3 Earths could fit side by side inside it. Jupiter is less a planet and more a star that didn't quite work out. A gas giant whose gravity shaped the fate of the entire solar system. And then comes Saturn, perhaps the most beautiful of all the planets, adorned with its majestic rings. These rings, which shine like halos of light when viewed from afar, are composed of billions of fragments of ice, dust, and rocks, each orbiting independently in a synchronized dance. Saturn itself is so light for its size, composed almost entirely of hydrogen and helium, that it would float if you could find a bathtub large enough to put it in. A delightfully absurd thought. In the farthest reaches of the solar system, where sunlight arrives pale and weak, we find Uranus and Neptune, the ice giants. Uranus is peculiar, spinning on its side like a fallen top, its axis of rotation almost parallel to the plane in which it orbits. Something, billions of years ago, must have struck it with enough force to topple it in this way, and so it remains, rolling through space in its eternal orbit. Neptune, the most distant of the large planets, is battered by the most violent winds known in the solar system. Storms that roar at over 200 kilometers per hour. Speeds that would make terrestrial hurricanes seem like gentle breezes. And then there's Pluto, the small icy world on the dark frontiers, which we once called a planet, and then, in 2006, downgraded to a dwarf planet. Not because it changed, but because our understanding of the cosmos deepened. Above us, every night, our faithful companion, the Moon, silently watches. She is Earth's only natural satellite, born, it is believed, from a catastrophic collision billions of years ago. Her gravity pulls on Earth's oceans, creating the tides that rise and fall in an eternal rhythm. But the Moon will not stay with us forever. Each year, she moves. 8 centimeters away from us, slowly escaping our gravitational embrace. Billions of years from now, she will appear smaller in the sky, and eventually, the total solar eclipses we so admire will no longer be possible. And we're not alone in having moons. More than 200 known moons orbit the planets of our solar system, each a miniature world with its own story. Europa, Jupiter's moon, may harbor oceans beneath its icy crust. Titan, Saturn's moon, has lakes of liquid methane and an atmosphere denser than Earth's. Each of these small worlds is an unexplored frontier. Breathe slowly. Feel embraced by this knowledge. You orbit an ordinary star in one of the arms of an ordinary galaxy, but even in this seemingly insignificant corner of the universe, there are enough wonders to fill a lifetime of contemplation. Let us now contemplate the stars themselves, those cosmic beacons that dot the darkness of the universe. Each one has a story, a birth, a life, and eventually, a death. And all these stories begin the same way. In nebulae, immense clouds of gas and dust that float through space like cosmic ghosts. In these clouds, under the pressure of their own gravity, the material begins to concentrate, to heat up, until finally, at the heart of an increasingly dense knot, nuclear fusion ignites. A star is born, shining for the first time, radiating light into the surrounding darkness. A star, like our Sun, will live for about 10 billion years, a period of time so vast that it defies human comprehension. During all that time, it burns hydrogen into helium in its core, maintaining a delicate balance between gravity, trying to crush it, and the pressure of nuclear fusion pushing it outward. It's a battle that will last billions of years, but it cannot last forever. When a star finally dies, when its fuel runs out, its fate depends on how massive it was in life. A smaller star might become a white dwarf, a dense, bright, stellar corpse, slowly cooling through the ages. A larger star might collapse into a neutron star, an object so incomprehensibly dense that a single teaspoon of its material would weigh billions of tons, more than an entire mountain on Earth, and the most massive stars of all. They suffer an even more extreme fate, collapsing into black holes, singularities in space-time where gravity becomes so intense that it warps the very fabric of reality. But before that final collapse, many massive stars die in glory. A supernova is perhaps the most violent event that can occur in the universe. In just a few seconds, a dying star releases more energy than our Sun will emit during its entire 10 billion year lifespan. The explosion is so bright that it can, for brief moments, surpass the brightness of an entire galaxy. And it is in these apocalyptic furnaces that heavy elements are forged. The gold in your jewelry, the iron in your blood, the calcium in your bones. They were all born in the heart of dying stars. You are, literally, made from the remnants of ancient supernovas. The black holes that emerge from these stellar deaths are perhaps the strangest and most fascinating objects in the universe. They warp space and time around them in ways that defy our intuition. Near a black hole, time passes more slowly, and space curves so much that all paths lead inward. Nothing can escape once it crosses the event horizon. Not matter, not light, not information. It is a definitive point of no return in the universe. Among the most peculiar stars are pulsars, cosmic lighthouses that rotate so rapidly that they complete an entire rotation in milliseconds. They are neutron stars that emit beams of radiation from their magnetic poles, and as they rotate, these beams sweep through space like a ship's lighthouse. If the beam is pointed towards us, we see regular pulses of radiation with atomic clock precision. Our Sun, that star that seems so large and important to us, is actually just a medium-sized star. There are red dwarf stars, smaller and cooler, that will shine for trillions of years. And there are giants and supergiants, stars so immense that, if placed where the Sun is, they would swallow the orbit of Jupiter. Blue stars are the hottest, burning their fuel voraciously, living fast and bright lives. Red stars are the coolest, dying suns or dwarfs that burn slowly. Many stars don't travel alone through the cosmos. Binary star systems, where two stars orbit each other in an eternal gravitational dance, are surprisingly common. Some of these stars have planets circling around them, worlds where a sunset means watching 2 or even 3 suns disappear on the horizon. Imagine growing up in such a world, where the concept of night might be rare, where shadows always point in multiple directions, and the cycle continues. A star can explode, and from its ashes, a new nebula forms. This nebula, enriched with heavy elements from the dead star, may one day give rise to new stars, new planets, perhaps even new life. It is a cycle of cosmic rebirth that has been happening since the dawn of the universe. When you look at the stars in the sky, you are seeing light that has traveled for years, centuries, millennia, or even billions of years to reach your eyes. Each photon of light that enters your retina is a messenger from a distant past. That twinkling of the stars that we so admire, it's not real. Stars don't twinkle. It's our own atmosphere, turbulent and in constant motion, that distorts starlight, making it shimmer and dance. And what about the constellations that the ancients mapped and named? They are not eternal. The stars move, slowly but inexorably, and the shapes we draw in the sky will change over tens of thousands of years. The Sun itself is not stationary. It orbits the center of the Milky Way at a dizzying speed of 828,000 kilometers per hour, completing a galactic orbit every 225 million years. The last time the Sun was in this position in the galaxy, dinosaurs still ruled the Earth. Not all stars belong to galaxies. There are wandering stars ejected from their home galaxies by violent gravitational encounters, condemned to roam the intergalactic darkness alone for all eternity. They are cosmic exiles, traveling millions of light years through the void between galaxies. And among all these stars, the closest to us, besides our own Sun, is Proxima Centauri, a small red dot just 2 light years away. Just, a misleading word, for that distance is so vast that even traveling at the speed of our fastest spacecraft would take tens of thousands of years to reach it. And yet, in cosmic terms, it is our closest neighbor. Close your eyes. Breathe. Feel connected to this vastness. Every atom in your body was forged in the heart of a star. You are not just in the universe. You are the universe, experiencing yourself. Now that we've contemplated the stars, let's explore the worlds that orbit them. And here, reality surpasses any fiction we could imagine. Beyond our solar system, orbiting distant stars scattered throughout the galaxy, we have already confirmed the existence of more than 5,000 exoplanets, alien worlds of surprising variety. And these are only the ones we have been able to detect. there may be billions, perhaps trillions of them, waiting to be discovered. Some of these distant worlds are so strange that they defy everything we thought possible. Imagine a planet where it rains glass, not drops of water, but sharp fragments of silicates falling horizontally, propelled by winds blowing at thousands of kilometers per hour. On other worlds, the sky pours liquid iron in apocalyptic storms. There are even planets composed almost entirely of crystallized carbon, diamond planets, where the soil beneath your feet would be worth more than all of Earth's economies combined. There is a world called WASP-12b, so close to its star that it is literally being devoured by it. Stellar gravity is tearing material from the planet's atmosphere in a continuous stream, and in a few million years, it will have been completely consumed. It's a grim reminder that even planets can have tragic fates. And then there are the orphan planets, worlds that have been ejected from their native star systems, and now wander alone through the intergalactic darkness. Without a star to warm them, these planets float through the vastness of space, frozen and lonely, perhaps carrying beneath their surfaces the fossilized remains of civilizations that once knew the warmth of a sun. Back in our own solar system, the story of how we discovered Neptune is fascinating. It was found not by sight, but by mathematics. Astronomers noticed irregularities in Uranus's orbit and calculated that there must be another planet beyond it, gravitationally disturbing its path. And when they pointed their telescopes where the calculations predicted, there it was, Neptune, exactly where mathematics said it should be. It was a triumph of the power of the human mind over the vastness of the cosmos. In the gas giants of our own cosmic backyard, Jupiter and Saturn, colossal storms roar with lightning that would make any terrestrial storm seem like a distant thunderclap. This lightning is so powerful that it can be detected from billions of kilometers away, illuminating clouds of ammonia and methane in electrical spectacles that no human eye has ever witnessed directly. But it is the moons of these giants that truly capture our imagination. Titan, Saturn's largest moon, is a world covered by a thick orange atmosphere, denser than Earth's. On its surface, there are lakes and seas, not of water, but of liquid methane and ethane. It is the only other place in the solar system besides Earth with stable bodies of liquid on its surface. Imagine standing on the shore of a sea of methane, gazing at an orange sky where Saturn looms immense, occupying a huge portion of the horizon. Europa, Jupiter's mysterious moon, hides beneath its cracked and refracted ice crust a global ocean of liquid water. That ocean may contain more water than all of Earth's oceans combined. And where there is liquid water, heat, and chemical compounds, there may be life. Europa may harbor entire ecosystems beneath its ice, alien organisms swimming in absolute darkness, nourished not by sunlight, but by chemical processes in the depths. Enceladus, another Saturnian moon, is even more dramatic in its revelations. From fissures at its south pole, it spews enormous jets of water into space, like cosmic geysers. This water comes from a subsurface ocean and contains organic compounds, the building blocks of life. Enceladus actively shows us that it has the necessary conditions for life. We just need to go there and look. Io, Jupiter's volcanic moon, is the most geologically active body in the entire solar system. Hundreds of active volcanoes cover its surface, spewing sulfur and creating a hellish panorama of bright yellows, oranges, and reds. Jupiter's gravity constantly squeezes and crushes Io, generating immense heat within it. It is a world in constant transformation, where the landscape literally changes every day. Mercury, so close to the Sun, experiences the most brutal temperature extremes. During the Mercurian day, the surface can reach temperatures high enough to melt lead. But at night, with no atmosphere to retain the heat, temperatures plummet to almost 200 degrees below zero. It's a world of absolute contrasts. Mars, our red neighbor, holds secrets of a gentler past. Billions of years ago, rivers flowed across its surface, oceans covered its northern plains, and perhaps, just perhaps, microscopic life thrived in its waters. But that Mars is gone, its atmosphere stripped away by the solar wind, its oceans evaporated into space. Today, global dust storms occasionally engulf the entire planet, temporarily transforming it into a uniform red sphere as seen from space. A Martian year lasts 687 Earth days, almost twice as long as our own year. On Neptune, deep within its atmosphere, the pressure and heat can be so intense that methane decomposes and carbon crystallizes. It can literally rain diamonds in the deep layers of that distant blue giant, with gems the size of rocks falling through oceans of liquid hydrogen. Uranus, that fallen giant, also has rings, not as spectacular as Saturn's, but still present, dark and faint, composed of material that absorbs almost all the light that falls on it. And Venus, our infernal twin, rotates in the opposite direction to almost all other planets. While most worlds rotate in the same direction as they orbit the Sun, Venus decided to be different. Perhaps the result of a massive collision in its distant past that turned it upside down. Jupiter, that giant among giants, is master of a veritable miniature solar system. 63 moons have names, and dozens more, too small to merit christening, orbit silently. And among them all, Ganymede reigns as the largest not only of the Jovian system, but of the entire solar system. It is even larger than the planet Mercury, a world in its own right, with its own magnetosphere and possibly subsurface oceans. Settle in more deeply. Let your mind wander through these distant worlds. Each one is real, existing in this very moment, whether under alien skies or hidden beneath layers of ice. After contemplating the vastness of the cosmos, the distant stars and alien worlds, let us now turn our attention to something closer and, in a way, more human. Let us talk about our own journey to the stars, about how a species confined to a small blue planet dared to dream of infinity. It all began in 1957, when humanity, for the first time, managed to put something beyond Earth's atmosphere. Sputnik 1, a small metallic sphere barely larger than a basketball, was launched into space by the Soviet Union. Its simple beep, transmitted back to Earth, was heard around the world. It was a signal. The space age had begun. Just 4 years later, in 1961, a young cosmonaut named Yuri Gagarin became the first human being to leave Earth and see our planet from space. Imagine what must have gone through his mind when he looked out the window of his Vostok capsule and saw the Earth. All of it suspended in the void, fragile and beautiful. "The Earth is blue," he reported in amazement. And 2 years later, in 1963, Valentina Tereshkova became the first woman to make this extraordinary journey, proving that the skies belonged to no gender, but to all of humanity. And then came the moment that defined a generation. In July of 1969, the Apollo 11 mission landed on the lunar surface. Neil Armstrong descended the ladder of the lunar module, placed his foot, covered in white boots, on the gray dust of the moon, and uttered words that would echo through history. That's one small step for man, one giant leap for mankind. And that footprint he left? It's still there, exactly as it was left. On the moon, there is no wind, no rain, no erosion. That mark in the lunar dust will remain for millions of years, a silent testament that once, creatures from a distant planet dared to walk on that alien soil. Today, orbiting the Earth, we have the International Space Station, this floating laboratory where astronauts from different nations work together above political borders. It completes 16 full orbits around the Earth every day, traveling at more than 27,000 kilometers per hour. And something curious happens to the astronauts who live there. They grow. Without the constant compression of gravity on their spines, they can gain up to 5 centimeters in height. Of course, when they return to Earth, gravity compresses them again, but for a time, they literally rise taller. The spacesuits that protect these explorers are marvels of engineering, each costing over $12 million. They are small, wearable spacecraft, complex life support systems that keep astronauts alive in the most hostile environment imaginable. But our presence in space isn't all glorious. Around Earth, a cloud of space debris orbits, millions of fragments of old satellites, discarded rocket stages, pieces of past collisions. Each of these fragments travels at incredible speeds, and even a small piece can cause devastating damage. It's a reminder that even in vast space, we need to be responsible. Our technological eyes have also extended to the cosmos. The Hubble Space Telescope, floating above Earth's hazy atmosphere, has already made over 1.5 million observations of the universe since its launch. It has captured images of galaxies being born, stars dying, and shown us the universe in a depth and detail that has transformed our understanding of the cosmos. And now, its successor, the James Webb Space Telescope, with its golden mirrors and incredibly sensitive infrared sensors, can see even further. It can capture the light from galaxies that formed in the first moments after the Big Bang, showing us the universe in its infancy. NASA, the American Space Agency, was created in 1958, and since then has led much of humanity's exploration of space. And among all the destinations we have explored, one stands out: Mars. More than 20 probes have already been sent to the Red Planet, making it the most visited world by our technology beyond Earth. Rovers roll across its surface, helicopters fly in its thin atmosphere, and orbiters map every detail of its geology. Mars calls to us, and we answer. But perhaps the most poetic of all our expeditions is that of Voyager 1. Launched in 1977, this small probe has already left the solar system, becoming the most distant man-made object from Earth. It now travels through interstellar space, carrying with it a golden record. On this record are recorded sounds of Earth, music, human voices in different languages, sounds of nature, and images showing the diversity of life on our planet. It is a message in a cosmic bottle, destined for any civilization that may find it in the distant future. It is our way of saying, we existed, we were here, this is our story. In space, even fire behaves differently. Without gravity to make hot gases rise, flames burn in a spherical shape and with a soft blue color. It's beautiful and strange, a reminder that the rules we know on Earth don't apply everywhere. And we cannot forget the first female space explorer, even though her journey was tragic. In 1957, even before Gagarin, a dog named Laika was sent into space aboard Sputnik 2. She did not survive the trip, but her sacrifice taught us valuable lessons about the challenges of sustaining life in space. She was a pioneer, just as much as any human. And here is, perhaps, the most humbling and wonderful truth of all. Despite all that we have discovered, all the planets we have explored, all the stars we have cataloged, all the galaxies we have photographed, humanity has explored less than 1/1,000,000,000 of 1% of the observable universe. Less than 0.00000000001%. We are newborns in cosmic terms, just beginning to take our first steps out of the cradle. There is still so much to discover, so much to explore, so much to understand. And as you lie there, comfortable and warm, consider this. You are part of a species that looked at the starry sky and decided not only to observe it, but to reach it. You live in a time when robots explore distant worlds, where telescopes can see the light of the first stars, where human footprints mark the surface of another world. You are made of stardust, inhabiting a planet orbiting an ordinary star in a spiral arm of an ordinary galaxy in a universe that may be infinite. And yet, somehow, you are able to contemplate it all, to marvel at its immensity, to ask questions about your place in the cosmos. Of all the wonders we explored today, this may be the most extraordinary of all. Take a deep breath. Let these ideas settle gently in your mind. You have journeyed from the beginning of the universe to the furthest reaches of human exploration. You have contemplated stars being born and dying, alien worlds of ice and fire, and the audacious journey of a curious species that dared to dream of infinity. Now, as you rest, know that the universe continues its eternal dance. Stars continue to shine, galaxies continue to spin, and somewhere out there, perhaps on a planet orbiting a distant star, another conscious being may be gazing at the stars, asking the same questions we do. We are not merely in the universe. We are the universe awakening to itself. Good night, sleep well, dream of the stars.